Great. Hello and everyone. Welcome everyone to Be Waste Wise webinar this month. I'm Akanksha Singh. As most of you all know, I'm the community builder at Be Waste Wise. And we've been organizing such waste dialogues on a monthly basis for knowledge dissemination on waste management since 2013. We are a non-profit organization and we've been bridging this waste solutions expertise gap worldwide for over a decade now. If you see the value in making such diverse sustainability dialogues such as these, then request you to please support us in our mission. We encourage you all to please do check out our website and donate. We'll be sharing the link for the donation page over the chat as well. Now, let's move on to today's topic of discussion. According to the recent stats, India ranked among the top 5 countries for e-waste generation, producing approximately 3.2 million metric tons yearly, and the number is only rising. So can we turn this growing crisis into a sustainable opportunity? Do we have any scope to meet our challenges and make this as an opportunity? In today's webinar, we'll explore these growing challenges of electronic waste in India and the urgent need for sustainable and circular economy solutions. To moderate this session, we have with us today Professor Dubey. Professor Brijesh Dubey is presently Professor of Resource Recovery and Circular Engineering, Department of Civil Engineering, and the Chair of School of Water Resources at IIT Kharagpur. He's very well known globally as a water resource management and life cycle analysis and decarbonization expert. He's one of the most oldest moderators on Be Waste Wise platform, and he has been moderating such eventful and very crucial topics on our website, on our podium. So thank you so much, Professor Dubey, for taking time out. Today with him, we have on panel two very eminent and very prominent voices in this particular industry. Dipali Sinha Khetripal. She's a co-founder of EcoWork with over 20 years of experience in the waste management sector, especially in the domain of EPR-related waste streams, such as e-waste, plastic, solar waste, and ELVs. We have, on the other hand, Dr. Praveen Kumar. He's the independent e-waste consultant. He has been working as an independent consultant specializing in electronic waste and battery recycling for the recovery of valuable materials since April 2025. Dr. Kumar has been recognized by CSR India as a domain expert group member for his contributions to lithium-ion battery recycling and e-waste management. Unfortunately, Abhishek Agassi from Alima will not be joining us as last-minute medical emergency. Before we proceed with this discussion, I would like to make a few announcements. This webinar is being recorded and will be uploaded on our website and YouTube channel. We request you to please use the Q&A function for your queries to the panel and use the chat function for all your comments, your study material, whatever opinions that you have, some links that you want to share, some pilots that you have generated on electronic waste, or some some information that you want to share. Please use the chat section for that. We'll be sharing our panelists' LinkedIn profiles in this function for whoever wants to connect them with them personally. So back to the panel and over to you, Professor Dubey.
Thank you, Akanksha, for giving the introduction to all of us. So by this time you already know. So for the next 1 hour or so, we are going to focus on kind of what is e-waste, what is electronic waste, and what are the issues associated with electronic waste in terms of how much it is generated. Some facts and figures we'll hear with Madam Dipali first in terms of different issues associated with the electronic waste, including how it is being managed presently in India, in other countries, in other experiences from her from European and other countries. What are the best practices? And at the same time, we will also go towards the solution side, like how to do the resource recovery and other stuff from Dr. Praveen Kaushik. So before we jump to individual panelists, I'll just very briefly, electronic waste is whatever you, anything with the circuit board, anything you put it into your power socket, when you don't use it. See, anything becomes waste when you throw it away, when it doesn't have value for you. As long as you are using it, so for example, right now we are using this laptop, or you might be connected to a CPU, to a desktop computers. So those are electronic products or your microwave, your dishwasher, your washing machine. You look at your houses, your kitchen, drawing room, everywhere you find variety of electronic products which we use on a day-to-day basis. But when it becomes not useful for us, it does not mean that it is a waste, it is not useful for others. So it has lost usefulness for us, so we put it in the waste stream. So either through the some sort of recycling system or some kabadi walas, or they will come and they collect it from us. And in the process, we do expect some money also from them, especially in India. Whenever we give our electronic waste to somebody, we want some money. Many Western countries, possibly Madam Dipali will talk about that a little bit. Actually, you have to pay money to get rid of electronic products from your home. So there are different ways people look at. So those are, once you throw it away, it becomes your waste material. And that waste material still has lots of precious metal, has people like your plastics are there. Older, if you look at the older electronic waste, we had good amount of glass, good amount of metals. Those percentages are going down. So, but newer things are also coming up. So we'll kind of wrestle that how to manage this electronic waste with all the rules and regulations in place that we have today, as well as what are how the business models can be developed. So both aspects will be covered. So without taking further time, I'll just directly to our panelists. So let's start with Madam Dipali Sinha Khetriwal. So ma'am, it's your time for next 10 minutes or so to kind of take us through this whole area, like whole subject of e-waste management, and share your experiences, please. You are unmute, ma'am. You are muted, sorry.
Sorry. So saying thank you everyone for joining, and Dr. Dubey and Akanksha for organizing and hosting this webinar. It's always interesting to talk about e-waste. I've been in this space for about 21 years now. I've seen it evolve, and it's more interesting to actually get questions. So I want to keep my own slides very short, and I'll be really glad to hear from the participants. We have a very open discussion then. So let me just pull up a short presentation just to get things going. Do you see the screen fine? Is it okay? Okay, great. So I thought, since the topic was focusing a little bit on the e-waste landscape in India and, the problems and solutions that we have, which are not exclusive to India, of course, and are probably common to many other countries. I'll talk a little bit more about what we've been through in the past, 10, 15 years in India, but also, of course, linking it to other global trends, right? So I think the very first place to start is the Global E-Waste Monitor. This was from the last year's Global E-Waste Monitor, which put the total amount of e-waste generated in the world at 62 billion kgs. That is a huge, huge number, right? So that is 62 million tons. And, if there are many different ways to look at it in terms of how many times you could go to the moon and back, or how many trucks you can have lined up around the world. But basically, it's a lot of waste out there. And what is really
Kali, I'm interrupting you. Sorry. Can you put this as a
full screen?
slideshow? Yeah, because we'll be able to see the figures properly. Thank
There
you.
you go. Is that better?
Thank you so much. Yeah.
Sorry for that. So 62 billion is generated around the world, and only a very, very small fraction. You see the left side, the tiny green, 13.8 billion is actually documented as recycled. The rest of it is going into many different ways, informal recycling, landfilling, some of it is going into reuse and refurbished kind of devices, which are
It's
there.
still not on slideshow. Can you, I think you may have to share the entire screen. You might be just sharing that's the problem of MacBook sometimes.
Oh, okay. I am sharing the slideshow.
Yeah, if you can just unshare first. And while sharing, you say sharing the entire screen.
Okay. Please stop share.
Yeah, if you can share the entire screen.
Green. Now we have an infinity mirror for a few seconds. Okay, there
Yeah.
you go.
That's great. Yeah.
All right. Thanks for that, Dr. Dubey.
Hmm.
Sorry for that. So yeah, so as I was saying, we have still a long way to go in terms of recycling and, getting back all the many different types of materials that are in e-waste. And I think, Dr. Dubey hinted at it. There is a lot of precious metals, there are a lot of basic metals, critical raw materials, all of these, very important elements that are found in e-waste. So in now is it stuck? Oh, there we go. So in India, we've been actually thinking about it for a while. Europe was leading this, already from 2004. There's been legislation in Europe as the WEEE directive, as it's known. In India, we've had some e-waste management rules since 2011. And these started off as very, very simple rules in a way where, it was introducing the concept of extended producer responsibility, similar to Europe. It did not have any targets at the time. It looked at only a few products. Over time, because of many drivers, these rules were amended, they were adapted and revised. And introducing collection targets, including the element of a PRO, producer responsibility organization, extending the scope of products. So you had, an evolution of the rules. And with that, of course, came other challenges, right? So again, to correct those challenges, the rules evolved in 2022, where it was, to extend the products even further, the scope, to create a much more recycling-oriented legislation, and also make it easier to comply. Which was, one of the challenges from 2016, which was, quite onerous on compliances. So this is how the e-waste management rules have evolved, and with the overall aim to improve e-waste management in India. But of course, there have been unintended consequences. So, some of the drivers for revisions have been these kind of challenges and, unintended consequences, right? So initially, when the rules were simple and light, you did not have a lot of compliance. A lot of producers who were supposed to take up their responsibility were being very shy about it. So you had to put some pressure from civil society and judiciary, which led to the 2016 rules. But this was, again, something that was pushing things, out of the level playing fields. There was a lot of inconsistencies. There were a lot of gaps in compliances. And of course, there was large scale paper trading, which is still going on. It hasn't been corrected. Uh, but that was one of those drivers to change it, to make it more digital, to bring some more traceability into the system, have a little bit more of ease of doing business through reporting online, etc., and bringing some credibility and assurance through a program of audits, and also introducing the concept of penalties. Have they actually been implemented? Are they working? I think these are all questions that would be great to discuss. It is something that is still very live. There is a lot of dynamism in this space in India, as if there are anyone joining might know. So yeah, the overall aim was to improve the framework conditions, the infrastructure, and the compliances. And this meant that the compliance strategies was also changing, right? Like earlier, what you had to comply against, for example, collection targets, changed to becoming compliance by buying EPR credits from the portal, where earlier you had to make sure that your compliance centers were, as per the guidelines, as per the requirements. Now you did not have to worry about the collection at all. You have to really just focus on the 4 metals that are part of the EPR credits. So these things have evolved. These things have meant that the focus on collection has also moved from collection to recycling. And there's been a whole skew in the market, in terms of how financing is, how fees are, and, what is, the opportunities for rent seeking, right? So how can you basically create paper EPR credits? So there have been hits. I mean, definitely there are some successes that we've had in India. There's been a lot of producer awareness. A lot of producers are now registered on the portal. They are aware about EPR obligations. There has been an impetus to the recycling industry. You have over 400 recyclers who have joined up, are authorized, are registered on the CPCB portal, which is the Pollution Control Board. There has been a lot of obligated credits that have been generated. So there has been, some progress there. And I think most of all, it has created a very large pool of money, right? You have over $300 million. There are very, very basic estimates, right? If in India, we're generating about 4 million tons of e-waste, there is a recycling target of about 60%. So if you just, multiply that and you take a very small, tiny average of rupees 10, that is what the figure will come to, right? So $300 million is a lot of money every year going into the system. So we should have a lot more to show for it. But that's where we have, all these misses where there is still, some friction in how the portal is working. There are still a few guidelines that are missing. Some of that implementation through assurance and audit frameworks is still to be implemented. It's still, a free market for paper credits. So yeah, some of those things remain challenges, and that's where I think there is, a conversation to be had between what is the potential for recycling and then what are the perils. Here in India, as a lesson to the world as well, to not make the same mistakes that we've had, to go through, and also to be, able to learn from others and improve our system in India. So I'll leave it with that, just to make a quick introduction to e-waste in India and hand over back to Dr. Dubey to take things forward. And happy to take questions later on. Thank you.
Thank you, Dipali, for a very good overview of what's kind of going on in the country and also some of the global aspect there as well. So of course, yeah, we'll get back. And I just, for all the people as an audience, feel free to put your question and answer. We have a question and answer section of the webinar. Put your questions there. Don't put it on the chat. Sometimes it gets lost. Put it on Q&A section. And we will be more than happy to answer all that question. Actually, we look forward to having a question from you so that we can have a good dialogue. It's just a dialogue between all of us. And I see people from around the world who has joined in. So even the people who are from UK, from South Africa, even from Pakistan, and I see people from Nigeria. So share your experience too on that in the Q&A section, so that we can take it up and talk about it. So now we'll go to the next panelist, Dr. Praveen Kaushik. You already heard his introduction. So he works more on the solution side, like from the business side. So Dr. Kaushik, time is yours now for next 10 minutes or so. And you kind of walk us through how to make good business model, how to make good business and do all this resource recovery of precious metals and others. Please go ahead.
Thank you, Dubey sir. Thank you all for joining. And thank you, Dipali ma'am, for setting up the context. And yes, you have gone through these rules and regulations which evolved from 2004 to 2022. You have given an introduction about the Europe context and then the Indian context also. And if the audience has observed, then there were the collection target and then there the recovery targets. So the first mechanism was how to collect these kind of items. So still the main challenge in the ecosystem is about the collection. And then regarding the resource recovery or the resource efficiency. So collection have always been a challenge, whether these are electronic waste or these are lithium-ion batteries, these are plastic, or whatever the waste item mentioned on the CPCB portal. So collection again in the form of a recoverable kind of collection mechanism. So for example, we know that still in India, we are struggling with this municipal solid waste where the mixed waste is coming still to the MRFs. So the source segregation is must. And when we say source segregation, it simply means that those who are segregating, they should know about the waste. So more and more awareness is required regarding the sources or regarding the resources. So once we stop looking the waste kind of item as a waste and we consider that as a resource. So partially we consider these items as a resource. That's why we expect some value against these items. But more awareness, more knowledge will further help in negotiating also, and it may give the end consumer a better value of the product as well. And second, once the end consumer is aware of the material composition, then they can better source segregate at their site only. Say, for example, in the e-waste, as Madam mentioned about the global e-waste monitor. So I have shared the link on the chat box also. So one should go through it, and one will find that around 20 to 30% of the material in the e-waste is plastic. And this plastic is not a single type of plastic; it's a mixed kind of plastics. There is PC, there is PVC, there is PP, there is HDPE, there is HIPS, there is thermosets, likewise bakelite, polyurethane foam. There is glass, other than the plastic, which is making a huge kind of proportion of the e-waste. Then there are other metals like copper, aluminum, iron, which we consider as base metals. But sometimes these copper, aluminum, irons kind of stuff is easy to recover. For example, if this is the part of the winding of the motors or in the form of wires, but when the copper is a part of the PCB, printed circuit board, then it is a challenge. Likewise, there are different kind of PCBs, different kind of fiber reinforced plastics or materials are being used in the PCB making. So there are different mechanisms, there are different ways by which these registered recyclers are taking, and the non-registered recyclers, which we generally call it unrecognized or unorganized sectors. So there are different mechanisms for the recovery of different metals. Some metals we can recover, some we generally forget, and we send it to TSDF. TSDF is treatment, storage, and disposal facilities. So my aim is to spread awareness regarding the materials, and then about the recovery, then about to decrease the volume that we are sending to TSDF. Because if we are sending something to TSDF, so first thing that we have to pay when we are submitting or depositing that item to TSDF or sending to TSDF. So they are huge charges. Likewise, in some cases, 10 rupees per kg, some 20 rupees per kgs. There are again a backward kind of carbon emissions also. So first you recover these material, you collect these materials, then you bring it to your recycling facility, then you send this material back to your nearest TSDF. So there is a whole life cycle assessment is required when we are dealing about the waste. There should be a local mechanism of collection, because when we say, for example, we are in north, say in Haryana, and if we are saying that we are collecting from Chennai, it is not making sense in terms of environmental perspective. There are a lot of recyclers perhaps in each and every state now, and there are states like Maharashtra, Karnataka, where the number of recyclers are perhaps the maximum. So if the local supply is not there, and they have to send it to, say, for example, to the north or to the west or east, then there are some gaps. It has to find out that why these kind of materials are not supplied to the local recycler, but going to some way around 1000 kilometers or say 1500 kilometers away. So there are some gaps. If somebody is paying better price for this much distance of logistic cost, then someone have to think about it. Even the CPCB or the regulators have to think about it, that what is happening behind the price mechanism, what any recycler is offering. Then it is about collection and resource recovery. Then if I talk specifically about the products, then for example, there are some volumetric products, likewise a refrigerator, washing machines, coolers. Then there are some more gravimetric products, likewise microwave oven. So one can easily go to their kitchen and try to pick up a microwave oven. Then the weight of microwave oven is perhaps similar to sometime, it depending on the size, so it is quite heavy. And the same case of AC outdoor units are a kind of gravimetric product, but indoor units is again, it is a volumetric product. So the logistic cost is finally depending upon both these factors, likewise your gravimetric and volumetric products. So for example, in a 30-feet truck or 20-feet truck, if you put, say, some refrigerators, so the weight is quite low, but the volume is quite high. So is it a kind of logical method or logical pricing system when you are paying for refrigerators only to bring some material from down south to north? It doesn't make any sense. But yes, if these are PCBs, these are batteries, these are black mass, or these are, say, your crushed PCBs, if it is gravimetric, then it is good. then it makes some sense. So there should be some local mechanism of dismantling these volumetric product, so that there should not be a larger footprint, larger carbon footprint, which is finally involving in the resource recovery segment. Because when we talk about resource recovery, then it is about resource saving also. So if we can save some kind of fuel, some kind of energy, at least at this logistic front, then again it makes some sense, both for environmental and for financial as well. Then after collection, when it goes to the resource recovery site, say for example, an electronic waste, registered electronic waste recycler or the battery waste recycler, because when we talk about electronic waste, then these batteries, e-waste, all these stuffs covers, although there is separate rules for battery waste management rules. But yes, these batteries or these cells are the inherent product of these electronic waste, likewise mobile phone, laptops, and there are other kind of stuffs, likewise your power banks, etc. So once it is collected, then transported by logistics way to registered recycler facility, then there are different steps, different mechanism. There are different kind of forms that need to fill by the transporter, by the both the parties, from the receiver and the sender. There have to be an insurance of the product, though it is a waste, but finally it has some economic values. So once it is received, then it is weighed, whether the weight that we started and that we ended at the facility is same. There should not be any pilferages in the midway. There should not be some kind of wastage, or there should not be some kind of, say, because these e-waste or these other kind of stuffs are also considered under the hazardous kind of activities. So once these reach to the recycling facility, then there are different activities depending upon the product category. Then these are segregated. And say, for example, you cannot process microwave on a refrigerator line. So there should be separate lines for refrigerator, separate line for microwave, where dismantling activities are something different. Likewise, microwaves has different kind of components. Your but you say washing machines, I have different LCD, LED panels are different, and there are perhaps 106 or 108 product categories. So they are, when you deal it with the plastic segment is also different. The volume is also different. The labor environment is also different. Sometimes you feel so that for the small kind of equipments like your mobile phones, whether you want to dismantle manually by labor or you want to just crush it. So depending upon the size, shape, or you can say form of the material, then you choose a different kind of process. Likewise, in case of lithium-ion batteries also, whether these batteries can be refurbished, then you have different methodology. But if these have to be recycled, then you have to adopt different methodology. Likewise, just direct crushing, shredding, and finally convert into black mass for the recovery of copper, aluminum, etc. So one have to get an overview in some cases, and in some cases deep understanding of the material, that how to process it, because there are some inherent hazards also involved when we talk about these electronic gadgets. Sometimes these are having the cells, and these cells may be having some potential. So you can't put some electronic waste directly into a shredder when these are having some kind of flammable substances. You have to get it separated and then process it in a different manner. There are SOPs, there are publications, there are other methods where one can go through that, how to dismantle these items. There are different courses are also available by Ministry of Electronics and MITI, and they have done some train the trainer kind of activities also, where these dismantling activities can also be seen. There are the reports also from where one can get educated regarding these kind of capacity building program for the trainers and for the skilled or semi-skilled laborers as well. So in case of base metals like copper, aluminum, iron, there are no much challenges. One can easily identify it based on their color, based on their magnetic properties, based on their uh, uses also. So these are easily segregated. Then generally these are baled. Like say for example, as per CPCB, uh, there should be a furnace for copper, furnace for aluminum melting. But yes, if these are not there, then still one can start these activities. The reason being, for example, iron. So you do not have facility for smelting or for any process downstream for the iron, which is a huge kind of stuff. So depending upon your activity, small scale furnaces can be there for copper and aluminum, but these have been made mandatory by CPCB that you should have these. But again, depending upon the volume, say for example, if you are generating copper and aluminum and you are selling it to another recycler, you can do this activity, because finally you are tying up with a registered recycler. So finally the responsibility lies on the next partner. So there are such arrangements. The tolling arrangements are also there. One can do the dismantling activities. Likewise, there are tolling arrangements for lithium-ion battery processing as well. Likewise, one can generate black mass and another can process it by hydromet route. So in case of PCB, copper is also there, and around, depending upon the type of PCBs, whether it's single layer, double layer, multiple layer, what kind of the material these PCBs are recovered, whether it is from laptop, whether it is from hard drive, whether it is from your computer servers. So these are having different metal contents in terms of gold, in terms of precious metals, in terms of copper percentage also. Likewise, some may have 10%, some may have 20 or 28% also. So this copper is in the form of foils there, but it is sandwiched between many layers of these FR kind of material, fiber reinforced plastics. So then these fibers are glass fibers, these may be epoxy fibers. So you have to delaminate these metals. So there are physical way of separation, likewise mechanical route, where you have shredders, you have hammer mill, you have multi-stage kind of equipments, different sieving, different air purification called systems, where the dust which is generated during the process, it is eliminated by specific type of dust collection mechanism. There may be some kind of precious metals in the dust, so one have to take care whether when they are sending this dust to TSDF, then they should quantify about the precious metals. Although at this stage the precious metal recovery from the dust or from other kind of stuff is not that much commercially viable, the reason being sometimes we are not aware of that metal content. Say for example, the easiest way is to do the XRF, and XRF is not that sensitive in terms of the waste which is generated from the copper PCB, from the PCBs, because finally XRF is a point kind of source. It is not just like ICP or AAS. So there are some challenges inherent with the techniques. So along with other researcher, I am trying to explore the bio route of leaching these waste out of the PCB waste, actually. The waste that remains after processing the copper PCB from the PCBs, that whether some kind of biometallurgical route can be explored, which can be more environmental friendly, less kind of economical concern, less hazardous or less harmful acids which can be there. So these routes can better help in sending less material to the TSDF, because glass, whatever kind of display is there is glass, and this glass is generally ITO, indium tin oxide, ITO coated glass. So the ITO coated glass is not finding any use as such. The commercial viability of the process is not that much. Still, recyclers, even researchers are struggling to develop a commercial viable route for the resource recovery of the indium and tin from these ITO coated glass, because the layer is in micron, in nanometer, perhaps not in micron. So the nanometer thickness simply contributes the material in ppb level, parts per billion, rather than parts per million. Say for example, gold is there in the ppm, silver is there in the ppm, but these indium tin kind of materials, although these are in the rare kind of element category, but these are in the ppb level. So developing a commercially viable solution for these is still a challenge. There is puff polyurethane foam, which is there as a insulating material in these refrigerators. So puff is still being struggled by the recyclers. So it is not finding a better way of disposal. So there are some materials, likewise thermosets like bakelite, etc., which the researcher can better suggest the ways how to tackle these kind of waste. Otherwise, what I feel that whatever metal is there, and it is, if it is in a sufficient quantity, then it is not making much a challenge to the recyclers to develop a solution. There are institutions like IITs, like CSR labs, which have developed proof of concept for perhaps recovery of each and every material. But the commercial angle is different. They have developed the processes, but the commercial viability is still a challenge. Generally, these are lab scale processes. These are not demonstrated at the plant scale. The cost to benefit ratio finally led to the recycler only. They struggle with the scaling up of the process. Say these processes are, as I mentioned, on the lab scale, 1 kg, not in 1 kg, 1 liter or 2 liter, hardly 10 liter scale. So from 1 liter to 1,000 liter scale, it takes much time. and sometimes technology is being transferred to the recycler, then the trained manpower is again a shortage at the both stages, whether it is MSc, BTech in chemical engineering, or these are diploma in the chemical engineering. So these manpowers are still lacking. So yes, in terms of creating a business model around the e-waste, I always suggest that as many as possible uh, players have to enter into the domain so that they can better get a flavor what is e-waste, what are different components lying in that. As many as people will enter into this field, then more and more association will be there. Likewise, sometimes we feel that we all recyclers are competing with each other, but it is not true, because finally the workforce which is working at each and every recycler, so the workforce remains exchanging. Say some staff is working with me, then they may go to Dipali ma'am, and after 1 or 2 years, then they will come back to me, or they will go to somebody else. So at the back end, there is a collaborative approach. It is not a competitive approach at all. So whatever the know-how somebody is having in my lab, after 2 years, it is going to serve somebody else. And there is always a network. Say, for example, as a researcher, we keep on communicating with each other. We do not feel that there is some competition. We keep on following each other's publications. We keep on validating each other's findings. So how we can say that we are competing? No, the resources are not limited in this case. The resources are huge, and more innovative approaches are developed by the researcher, which keeps on moving from one company to another, and company pays for that. Likewise, if I train someone in my lab for 2 years and then he wants to go to the Polymer, then definitely he will get an increment. And the reason of that increment is the knowledge that he gained in last 2 years. So or she doesn't start from the scratch. He has a knowledge and company is paying for that, and it is simple. So what I am finding that technological solutions may have some advantage, but the business plan that one make, more outreach activities they perform in terms of collection, in terms of awareness, that remains a parallel challenge along with the technical issues. As I mentioned, that if, for example, somebody is associating with Dr. Dubey and he asks him that please train 2-3 manpower for us in your lab, then he is happy to have. Because finally, these 3 to 4 manpower is asset or is a lifelong association with both these partners for the industry and for the academia. And these kind of activities have to happen where industry can send their manpower to some institutions for training purpose, and then vice versa. So these mechanisms have to evolve in a better way. There are industry sponsored projects also. Likewise, uh, two of my students one has done the PhD from a CSI lab, another is doing from the DST lab. So they are both from the industry. So they are both sponsored by the industry, and whatever he gained in these 4 years, it is going to mutually benefit both these institutions, likewise DST, likewise CSR. And same happens in IIT and other labs also. So overall, such kind of association is important because I am now seeing that the BTech or the MTech guys are also venturing into it, into the recycling sector, because they think that they have a better understanding of the material. But the problem with the scientific community is that they do not have the financial education. So that's why there are some lacking between the conversion of the technology into a product and into the commercial viability. So yes, curriculums are being evolved where these science students may get some flavor of the financial side of the business, and that's why the business role of business models comes in, where they try to, you can say, take up the project in the form of some pilot activities. They can start this activity from their institutions only. They can start collecting this material from their central warehouse, which is perhaps their central store, which is perhaps there in every IIT, any CSI, or any lab. So there can be a mechanism where the inventory, which is just written off from the record of any professor or from any staff, so this should be provided for the learning of the masses, likewise BTech or MTech graduates. They can start harvesting the materials. They can start exploring the different routes of processing these items, and this way perhaps they will get the flavor in terms of some kind of internship on these activities. And for that, they need not to join any industry, because these items are lying with each and every human being. whether these items are placed in their houses or in their hostels or in their institutions. So for that, they need not to go to directly to any e-waste recycler. I'm still getting calls that somebody wants to visit the e-waste recycling facility, and then I try to arrange those activities also. But I suggest them that I have videos of a lot of recyclers, and there are videos of a lot of recycling activity on online. And I suggest them that if you go to the recycler, then you can't learn anything. The reason being, when you go to the plant, then there is so much noise, you can't communicate. You are shouting, I am shouting, then there is nothing. So better to watch the videos which are available online and just try to explore the material which is lying with you only. Generally, we have discarded laptops, discarded mobile phones, discarded such items. Likewise, pencil cells, likewise lithium-ion batteries, likewise power banks. So at a research level or at an amateur activity, one can easily see the video and dismantle these items. Then they will be see, say for example, in case of lithium-ion batteries, they can easily see that there is copper foil and aluminum foil inside lithium-ion battery. And say, for example, in case of zinc manganese kind of these pencil cells also, one can easily identify these items. There, the AI tools like Gemini, ChatGPT, Meta AI, etc., they can better, you can say, help them. So, as such, I believe that more and more people will be connected, then more and more awareness will be there, and perhaps we all who are here in this meeting, nearly 57 participants are there. So I am open to all of them, whatever they want to learn from me or whatever I can learn from them. So then I will be happy for those activities. So in conclusion, better awareness, better KYM, know your material kind of concept is important. And the key for material recovery is KYM. Once you know your material, then you can know the solution for its valorization. So that's enough from my side this time, Dr. Dubey.
Okay, thank you. Thank you, Dr. Praveen, for very elaborate description. I think I'm pretty sure audience must be have got a lot of insights from you. So we'll get, we have been having lots of question and answer coming on the Q&A while the panelists were discussing their viewpoint. And I see that quite a few of them, Deepali ma'am has already taken care, but and then there are some still there. So we'll get back to those questions one by one. And so before we jump to those questions, which one of those was already there as well on the TPR, extended producer responsibility. So Deepali ma'am, and during your presentation, you were talking about the EPR credit. So, and based on my understanding, although I'm not an expert of EPR, what I get a sense that people are more worried about getting the credit rather than doing the things right. So is it like how you would like to respond to that? And is it EPR really helping, or EPR has just become ki chalo ek tick box lagana hai, let's do the ticking of that by buying some credit, like the carbon credit that we used to have earlier as well. So yeah, please go ahead.
So I think that is a great question. And I think that is, at the base of a lot of these litigations going on currently, right? Like there is a case in the High Court where producers and recyclers have different opinions on what does EPR credits mean, how should they be priced, who should pay how much to whom, etc. And you're right. I think there is a huge scandal around it. There are news articles almost on a daily basis on how these recyclers are basically literally printing money out of thin air. It's really a sham. You cannot be doing that kind of recycling at that kind of level, with the kind of infrastructure we have. I've been an auditor, so I know what it takes to recycle it. We do actually run an operational plant as an NGO to really know, okay, if you have to do 100 tons, what does it take? So I think those EPR credits, the concept is great, right? Because the idea of extended producer responsibility is that the producer says, okay, my product is responsible, not just till I sell it, but also to make sure that it is collected and properly recycled. The reason why it needs that additional, extension of care is because it is uneconomic to do it from just the material point of view in the safest possible way, right? Like you can do it informally, you can do the cherry picking, you can look at only the gold and the silver and the platinum and the palladium and the nice shiny stuff. But there is also the hazardous part. You do need to take care of the lead, you need to take care of the mercury, all the things that Dr. Kaushik was also mentioning, in the know your materials. So there is a cost to doing that. You have to collect it, load it, transport it, aggregate it, process it. And then, there is a cost to disposal. There's also a cost for treatment. You need to pay rent, you need to pay, your labor, you need to pay energy. So all of that together does not add up to the material value, the intrinsic material value, as we call it. So if you have, a ton of e-waste, it's very, very likely almost anywhere in the world that it will not pay for itself. And you do need this additional top up, which is called the delta, which is what the EPR fees should fill in, right? Now, this EPR fees can change based on the type of product, in the type of infrastructure you have, in the type of, system that is there, right? Is it a collective system? Is it an individual system? There are many different implementation models in the world already to see, what are some of the tweaks you can do with this kind of funding. But at the bottom, you do need to have that funding. And the EPR mechanism in principle is great because it creates, uh, a kind of a ring-fenced fund to make sure that the e-waste is collected and recycled properly.
Thank you. And so, Dr. Kaushik, when we talk about e-waste in our class, as a professor, when I'm discussing in the class, I get a question sometimes from my students saying that recently in Japan, they could have Olympic medals coming out from this precious metal recovered from e-waste. So the question is like the student asked me when it will happen in our country, like when will we have medals being done from this precious metal recovered from e-waste? Do you see happening in near future, and what will make it happen?
Sir, it can happen anytime when the government and the recycler will wish. So finally the willpower is there, which is
Do we
the
have
main barrier.
technologies? We have the technologies in-house to do all that in an economical way?
Yes. Say, for example, in case of precious metal recovery, the technologies are not that much fancy. Generally, every recycler has this aqua regia based approach where they dissolve these metals. Say, there are different kind of activities. Likewise, in case of just an example of PCBs, because generally we mentioned that we recover gold from the PCBs. So in case of printed circuit boards, as I mentioned, there are diverse type of PCBs. So for the recovery of gold, silver, etc., so we collect those PCBs which have a significant impression of the gold, like the shiny golden color which is there. So we pick those PCBs, likewise from mobile phones, from laptops, from motherboards, from ICs, from RAM, from SIM cards, etc. And then we process those PCBs in different way. For example, sometimes directly putting those into the aqua regia, or there are other kind of solutions which are available commercially, where one can easily get remove these gold from the layer, because this layer is hardly in micron or some time in nanometer as well. So this micron layer of gold is removed, and then it is precipitated by different routes. This may be dimethyl glycozyme, this may be another kind of reductant which are helping to finally precipitating down the gold. Then there are approaches for silver as well. Likewise, in case of solar panels, so silver is there, so which can easily extract it.
There was another question also on solar panel. What is the most effective method? And in fact, one of the participant was claiming that solar panel recycling is not at all economical. So Dr. Vikas Chaudhary had that point.
Okay.
Yeah.
So good thing is that Vikas is my PhD student.
Okay.
So good part is that I like it that he is there. So Vikas mentioned that the aluminium frame is generally recovered by the other resources. But yes, the aluminium frame can be easily recovered. But yes, real technological interventions lies after separating the aluminium frame. So around 0.01 to 1% in some cases there is silver on the uh, cells, solar cells. but in terms of weight of the solar panel, it is less than 0.01%. But finally, there are two ways of dealing with the solar panels where the aluminum frame has been dismantled. So I have developed processes and I'm giving consultancy to an industry for recovering of this silver. And believe me, it is quite cost effective. And further, there are claims by other labs also that one can generate 5N, 6 and even 7N type of silicon from these silicon wafers. There are technologies available with Bark from NML, where the zone refining methods they are proposing. And I am also working with another institutions where trying to develop the zone refining method, which can be used for improvising the quality of the solar uh, silicon wafer, one can say, or silicon ingot. So technologies are available in India for lab scale kind of activities, but to convert them into the commercial scale,
Yeah, big scale. Yeah.
it's needed. Say for us, the easiest approach is to trade, which generally every person do when they enter, because trading is not some kind of secondary activity. It should be.
Developing the in-house capacity, like rather than sending things abroad for some of those recovery, in-house capacity as a workable plant, uh, that is needed, isn't it?
Yes, sir, that is needed, but the challenge lies with the scale of the technology. Say, for example, if some lab is claiming that they can recover 1 gram of the silver from the silicon wafer, but one have to deal with tons of the capacity. And good thing is that India has achieved 50% of the renewable energy capacity by 2025. It was targeted to 2030, but 50% is really a upload
Yeah,
kind
good.
of activity
Yes.
for Indian scenario.
Yeah.
And after 15 years, one should not wait for recycling the solar panel. The reason being, there is still a huge quantity of production waste is lying with each and every manufacturer. So they have to take care of these silicon wafers from those facilities only, and it is sufficient to deal with. So solutions are there. Silver is being extracted by a lot of recyclers. Gold is also extracted from by a lot of recyclers. So I think perhaps Atero mentioned at some place that for some Commonwealth medals, I don't know, somewhere it was in some news. So there was some activity. So
So, yeah, I think we can get to the next question. We have several of them. So, Dipali, there is always, whenever we talk about waste, whether you talk about municipal solid waste, electronic waste, this informal, formal, that discussion always comes in picture. And there are several questions on that, and you answered, I think, some by typing it in. So, how you see it? Like, personally, I also feel that there should be a good marriage between the informal and formal sector. The informal sector does a lot of wonderful job. So, how to really make it happen based off your more than 2 decades experience on the ground? What is your take on that?
That's really, at the crux of solving the problem, right? Like, how do you, get people who've been actually at the forefront of the circular economy, right? Like, they have been doing the collection, the recycling of electronics before it became common knowledge, before it became, regulated, etc. So, I think there is value to what they have learned, what they have done. I think the focus should be on how do we keep a lot of the good work that they have done, a lot of the network that they have built, and supplement that with the right channels to downstream where you need industrial processes, right? Collection does not need like, heavy duty formal infrastructure. If you can continue to do it, like we are in India, that's our strength. Hardly any e-waste in India goes to landfill versus, what you would find in the US or, in many of the OECD countries, right? So I think that part works well, and we shouldn't break what is already fixed, right? So where we need to fix things is where it starts to go into the downstream, to recover, where you need the aqua regia, right? Like, everyone can't work with aqua regia just in their backyard, on their rooftop, in the gully, that's like a little alley. So you need to have a way to channelize it, say, okay, you've done a great job with collection, maybe you can do some of the dismantling. But at some point, it needs industrial recovery facilities. And that's where we need that interface to happen, where we need to say that you can make good money by not doing the recycling yourself, by making sure that the industrial process, if it goes, for example, Hindalco, Adani, Tata Steel, they are all investing in large formal, recycling capacity. If they can say that, look, we are able to recover 80-90% of the metals in the PCBs, for example, if we are able to, get not just the gold and the palladium, but also, 4, 5, 6 other elements, um, our economics, our unit economics can be better than what the informal sector is recovering at 30, 40, 50%. So there is enough of an economic incentive for the informal sector to not do it, because that's their basic, argument. Like, we make money, this is our livelihood. If we can give them better livelihoods, if we can give them better incentives through better processing, I think that is going to pull the material away from the informal sector at the point it is necessary. When it starts to get dangerous, when it starts to get hazardous, when it starts to have the toxics and the hazardous waste effects. So that's how I think we can really, build a fair and harmonious e-waste system, which integrates the informal sector, but avoids the harm that currently happens.
Vijay sir, you are muted.
So yeah, thanks, Dipali. Whenever we talk about waste, that question definitely comes in formal. Dr. Kaushik, there is a question for you from Pooja Pandey. She's talking about like how to recover. What are the technology initiatives there for recovery of critical raw materials other than gold, silver, and copper? So other critical minerals, which is, and then along the same line, if you take the next question also, where no, the next question is slightly different. We'll take it later, and then talk about that circular e-waste solutions. That Santanu's question is there. You can see those Q&A. So if you want to respond to these two, that would be great.
So by chance I'm not able to answer all these questions, then you have my LinkedIn page,
Yeah.
and Akanksha may share my WhatsApp phone number also. So I will be happy to connect over both the channels. So please post those questions there. And for Pooja, yes, there are technological interventions being made by a lot of institutions, perhaps each and every eminent lab, whether it is IIT or CSIR or even DST labs also. But the challenge lies first in the segregation process, then the KYM, know your material activity. Likewise, for example, it is surprising that the electronic product manufacturer are not aware of the material composition that they are dealing daily. So we face the challenge when the role of EPR comes into the picture. Then it was asked by the manufacturer or the producer that what kind of items are present in your product. So they just share the MSDS. So it was quite surprising that they are still working with the MSDS. They do not have the product specifications. Say, for example, in case of lithium-ion batteries, we face this challenge. In case of PC, in case of each and every product, sometimes they have all this data. Say, if I ask an AC manufacturer that what kind of plastic is there in your indoor unit, then they are reluctant to answer. So finally, one have to reverse engineer. One have to take the help of the expert who are expert semi-skilled labor who are there in the plastic waste recycling. Then they tell us that this is ABS, this is PC, or this is PP. So why they are reluctant in telling that? So in the similar line, when we are talking about electronic waste, so real recycling happens where the material is composite or material is a kind of layered by layered structure, likewise glass, where the every skin has this kind of perhaps ITO based conductive stuff. There are PCBs, different type of PCBs as I mentioned. There are batteries. So there are some coatings. Likewise, galvanized kind of iron is there. For example, in case of your back panels of the LCD TVs. So most of the time, when the new recyclers comes in, they are not aware about the KYM. So they keep on struggling based on the inputs from the informal sectors only. So when somebody asks about the formal and informal association also, then I should comment on the technological part. So as Deepali mentioned, ma'am also mentioned, and likewise the Aquaregia kind of approaches. So they have gained a lot of know-how on the quantitative recovery of the item, but they have not optimized the process in terms of qualitative kind of activities. So they keep on polluting their own health first, then the environment. What I feel that India's need are different, Indians' needs are different. So these the first level collecting guys, they devise different mechanism that how to valorize their product. Where, say for example, if you move around your city, then you can easily find this polyurethane foam extracted from the refrigerator lying just in roadside. The reason being, they know that puff has no value, but the metal casing has some. So they try to valorize the product because they know that they have to convert the valorization, so it's the volumetric product to the gravimetric product. So in some cases, yes, there is no much technological interventions required, but for the critical metal recoveries, yes, there is research is going on, but the quantity is less. Likewise, these are there on the capacitors, diodes, transistors at this side only. So the processing for the recovery of these items, likewise tantalum is there, scandium is there, some other stuffs are there. So quantity is quite low. Commercial user in Indian market are less, so better they sell it to other even countries also by different routes where they can get better value other than in-house processing. And yes, it is always a subject of research that how much cost effective a process can be there, which can be demonstrable by the institutions at a pilot scale facility where the level of confidence of the recycler increases. They can easily put a commercial scale plant based on the pilot process inputs.
Okay, yep, thanks. So I think we are almost to the last question now, which is there on the Q&A. And hopefully, while it is being answered, there might be some more. We, as Akansha said, we'll go for another 5-6 minutes before we close it because we're already over time. So Dipali ma'am, this is this question from Santanu Kumar Sahu. I think you have seen the question. I don't have to read it. So talking about that entire circular business model in like funding and all that. So what's your take on this? You are on mute.
Yeah, I think, there's a lot of scope for innovation, definitely. I think there's scope for innovation on the operation side. So how do you, use technology to improve the recyclability, improve the, recovery rates? There's a lot of innovation already happening on the digital side. How do you improve traceability? There's also, elements on of research, like bioleaching, etc., using a lot of proteins to extract some of the precious materials, things very, very rare earths like neodymium, etc. So there's a lot of innovation, and I think that is also going to drive some of these conversations between business models, between where you need to um, have funding, what are some of the upsides, in the business context, right? So if you have a good technology, a good process, you can recover materials at a reasonable scale. I'm not even talking of hundreds of thousands of kgs, but even a reasonable scale. There are already markets which want secondary raw materials which come from certified sources. So having that supply chain is becoming important for many reasons, right? From geopolitical reasons, from just resource availability reasons. There is only so much of a certain material on Earth. So, much as we like copper, there's only so much of it. And, all the electrification that is going to happen is going to be based on copper. We are moving from a carbon economy to a metal economy. So making sure we can keep those metals in our economy, keep circulating it is, that massive business opportunity. So I'm sure there will be many different types of business models in just collecting, aggregating, recycling, recovering, keeping a track, making sure that you can improve the processes. So yeah, there's a whole world, I think, of opportunities and new products, right? Like solar panels, like drones, like humanoid robots, for example. So I think we are going not away from electronics, going into more and more.
And then see anything on the periodic table, we cannot create. We can only use it, misuse it, and then try to use it again. So it has to ultimately, it has to become circular. As the population is going up, with secondary materials are becoming inevitable now. You have to use secondary material. Just one thing, like both of you can comment on that. I recently visited Hatti Gold Mines, and there from 1 ton of ore, they are getting around 1.2 grams of gold. Some of the literature is suggesting that actually we have more gold in e-waste. So rather than mining those and creating that mining waste, which is, see, 1 ton minus 1.2 gram, it is essentially 1 ton of waste, mining overburden. So when the days will come when we will be mining this from electronic waste and other waste sources, not only gold, but other precious metals too. So is it 10 years from now, 20 years from now? Yeah, Dr. Kaushik, he wants to go first. Go ahead.
So, sir,
And then
good part is that it is already being taken care by our expert informal sector since decades. So
but they
we
do
know
it in a
that there
very
is a parallel
crude way.
economy in India.
Yeah, but Dr. Kaushik, they do it. I totally respect informal sector, but they do it. They don't have to meet all that CPCB, SPCB requirements. So there is a lot of that you can say the aqua regia will be in that water, nearby water. It creates a lot of environmental problem as well. So
Definitely,
yeah.
definitely, sir, rightly pointed. But the reason why I mentioned this, no any precious metal is going into the landfill. These are already being recovered, but by the unrecognized kind of segment where we do not have any GST track, whether we do not need any DIN number, where we do not need any transactions. So there is a parallel economy which is quite being operational in India since decades. So already these are being taken care. The second thing is that's why the role of EPR comes into the picture, where producer have to channelize its e-waste to the registered recycler, so that the less and less fragment go to these informal sectors. Then, if say for example, it is simple. If they are not getting a feed, then they have to go through a different mechanism of the feed. So that different mechanism can be getting a job to the registered recycling facility. So that can be a better integration way. So somehow we are, you can say, holding our ear either this way or that way.
Oh, that way.
So this is the way of channelizing or merging the informal into the formal. And as Dipali ma'am also mentions, if the first stage is the collection, and collection is being taken care by the so-called informal guys.
Yeah.
So in some cases these can be recognized, in some cases these cannot be recognized. But finally, the aggregator model which is already there, so the material which goes to the aggregator is being collected by these guys only, whom we call as the rag pickers, kabadi wala, etc. From the aggregator to the registered recycler, there is a journey. But yes, as Dipali ma'am also mentioned regarding the honesty and dishonesty. So somehow we have inherited more dishonesty than the honesty. So it is the behavioral, cultural,
Yeah,
social,
that's always there.
or
Yes.
family issue when we have to offer a chocolate or biscuit or something else to do the daily chore by our children, then it is being inherited only. So we need incentive to set our own bed? No, we may need some kind of encouragement, some kind of push, and that push can be anything. So there is a small quote in Mahabharat, Dandah Shasti Praja Sarva. So Dandah means there should have been some enforcement. So what kind of enforcement should have been there? Whether you are ready to give some kind of push to your kids that yes, this is your job, do it responsibly, instead of offering him some chocolate or something else. So the
Like we
mode
say, Sam
has
Dam Danda Bhed, na? Sam Dam Danda Bhed, there is also there. Yes.
so mode have to be changed, sir. So the
Okay.
responsibility towards the environment lies from the house, home only, from the families only. So once we, as a educational background people, if we are not concerned about our environment, about our resources, then just imagine how much difficult it is to convince the last mile kind of collector that it is not safe for you as well. So let
Okay.
us educate
Yeah.
ourselves, those who are there, 53
Sure.
participant, create
Sure.
the network, create the knowledge, and then come back again on the
Okay.
feedback kind of activity.
Sure. The final words, Deepali, maybe in 1 minute or so, because yeah.
No, I think, definitely I see this, as I mentioned, as a really exciting space. There is a lot that we need to do. So that means that, we have enough of opportunities to work in, in whichever way we want to, right? Whether it's working on the technology side, whether it's working on the communication, whether, building awareness, creating behavior change. So I think, these webinars are also part of this, and I'm really happy to have been a part of it. So thank you so much for the invitation. And I hope I was able to share a few insights, have a few, at least thought starters, and happy to, have questions come my way even later after the webinar. So yeah, please feel free to connect. I saw my LinkedIn was given somewhere. So
Yeah.
please feel free to reach out. I'm very happy to come back with any answers. So thanks a lot to
Thank you. Now over to Akansha.
Dr. Dubey, Akanksha. Over to you. Thank you.
Thank you, Dipali, and thank you, Dr. Kaushik, Dr. Professor Dubey, for sharing your insights. And I'm sure a lot of queries have been answered. And if there are any unanswered queries, then please do share it with us. And also, we've shared the personal LinkedIn profiles of the panelists. This discussion can go on and on, where there might be some subdivisions or subtopics. I'm sure we can take it up later on. Please do suggest. And thank you for taking time out, the panelists. Really, really appreciate your efforts. And as I mentioned, this webinar is being recorded, will be uploaded on our YouTube channel and on our website soon. If you want to keep updated on the future events, then please do visit our website, and also follow us on our social media and subscribe to our newsletter. Thank you so much again, and good day to all.
Thanks,
Thank you
everyone.
all.
Bye-bye.